Welcome back to OSS Master Series. I'm your host Balaji Kumar. Today we are stepping into the most transformative chapter of modern telecom operations, namely automation. This is episode 5 of the OSS Master Series. OSS automation and closed loop operation from workflow to autonomy. If episodes 1 through 4 explained how OSS systems evolved, episode 5 explains how OSS becomes intelligent, how it stops from being a passive monitoring system and becomes an active decision-making engine. As I mentioned, automation is the heartbeat of modern networks. Closed-loop operations are nervous systems. Together they form the foundation of an autonomous network. In this episode, we explore how OSS detects, analyzes, and decides and acts and verifies all at machine speed. Let's begin. Why automation matters. Telecom network is no longer simple providing basic telephone services. It is a complex network which can handle static infrastructure with dynamic, distributed, multi-vendor, multi-technology, multi-services ecosystem. 5G, IoT, Internet of Things, cloud, edge, computing, virtualization, all kinds of new technologies and associated services have multiplied and made this network complexities go 100-fold. Manual operations cannot simply keep up. Automation matters because networks are too large for humans to manage manually. Customer expectations and demand instant response. Outage of the network cost millions. The complexity is exploding. And speed is everything in terms of meeting customer expectations. So automation is not a luxury, but it's a survival for any telecom operator. And OSS is the foundation of automation for an operator. Automation in OSS is built on 3 pillars. Machine-driven, which is like computer-driven. Systems takes action without human intervention. Policy-driven decisions where rules, thresholds, intent, guide, behavior which are set by human beings and obviously varies from operator to operator. These rules defined as a policy and they make decisions. For example, in my early years of career, we used to put some policies. If the capacity on a given link exceeds 50 to 60% of the total capacity, we need to add more capacity because it takes time to do that. Those type of policies have to be put in place beforehand. Workflow-driven processes, multi-step tasks are orchestrated together in an end-to-end format where some tasks are manual and some are automated, running in the background, but in the end, it's seamless from a workflow point of view or from a process point of view, from a function point of view. In this case, automation is not one thing, it is an ecosystem along with manual activities. But before automation can work, OSS needs some foundations, needs clean, accurate, real-time data. And that's why when we talked about episode 4, the data is so important. Automation is not only good as data feeding it. In other words, data is the driving source to enable automation. There are 5 levels of automation. Namely, level 1 is manual, where humans do it, everything, which is how it started in the early years. Level 2, assisted, as computers get evolved. Telecom operators moved to this, so reducing number of human beings interacting to do the job. It provides recommendation. Then came level 3, partial automation. System performs some actions with human approval of human checklists, checking them on regular basis. And then full automation system can independently perform some tasks within the defined boundary and spit out results for humans to take it to the next step. Then came level 5 is autonomous. Systems understand the intents, takes in the policies, predicts the outcome, and then automatically self-optimize it to minimize the impact. Most operators today sit in level 2 and 3. The industry is pushing towards level 5. Now, obviously, there is a process and it takes time. As I mentioned in episode 4, the data is very important. At this point, the data is not there to help you to get to level 4 and 5 yet. Now, why manual operations don't scale? Let's start with that. Manual operations suffer from human error. So as humans, we tend to make mistakes, wrong entry, typos, pressing the wrong buttons at the wrong time, unplugging the wrong cables, all kinds of things. Also, the response times is very slow, high mean time to repair. So we call in industry, in support functions, MTTR, mean time to repair. What does it mean is, moment some problem occurs, it takes 2 steps to fix the problem. One is identification of the problem. Another one is going and fixing the problem. The whole process from when the problem occurred to fixing it, the whole thing is called mean time to repair. In other words, from a customer point of view, they don't care whether you're able to resolve the problem right away or the problem was so complex it took a long time to fix it. Bottom line is, my service is down and when is it going to be up? Operational fatigue and inconsistent decisions. This is obviously tied to humans. Operators are run by human beings, and based on the background, they make decisions based on the knowledge. Some people make decisions without all the information. Some people may overanalyze information and thereby delaying the decision-making process. So it's a complex aspects. And networks have to operate 24/7 and humans don't. So you need to have rotation of people who can cover 24/7 time frame expectations of a network. This is where automation automatically fills the gap. Event-driven automation is a first step of this whole automation evolution. It's a simple one. You trigger, condition, and action. For example, trigger can be a high CPU usage detected. Condition, if it is sustained for 5 minutes, the action is scale out the service or add additional CPU or reduce the service usage or service consumption, something like that. This is the foundation of modern OSS automation. Workflow automation, the engine of operations. Workflow automation uses a generic nomenclature or industry standard, you can say it, called BPMN model. It's called Business Process Model and Notation, where the industry sort of agreed on how to define various steps of the process and make it consistent so everybody can follow some nomenclature associated with that. And obviously tools are being developed to create that environment and incorporate it. This helps you to orchestrate a multi-step process and can be done without a lot of technical knowledge. Business users can do it because they understand the business. For example, provisioning, ticketing, fault handling, change management. All of these processes are complex within an operator environment, and these workflows can be coordinated between humans and machines and make this process a viable one. They ensure consistency, repeatability, and compliance. So when 2 persons look at the process, they can get an understanding, an agreement, yep, this makes sense, or we need to change this particular activity or steps has changed over time. In fact, within a company, usually you will have multiple processes to do the same function because of different regions, because acquisition of another company who have done things a little bit differently, and it takes time for you to integrate it, all kinds of variations. The next is policy-driven automation, consistency at scale. This is where thresholds, define thresholds, compliance, rules, intent, guardrails are put in place. Policies ensures automation behaviors predictably. I will repeat. Policies ensures automation behaves predictably. They prevent over-automation and keep the systems fail-safe. Policies are laws of automation. Next is orchestration, the conductor of network. Orchestration coordinates different heterogeneous domains or technologies or different systems in a seamless fashion from a layer above that or from a user point of view. There are typically 3 layers of orchestration. Resource orchestration manages the network resource. It can be equipments, virtual resources, physical resources, anything, any combination of that. Service orchestration manages the end-to-end services. To enable a service to the customer, operator has to what I call stitch together multiple segments of the network or services in a seamless fashion so that the user does not see any difference. Multi-domain orchestration. Now you're talking about domains like RAN, which is Zodiac's network, core, transport, cloud, edge, any other domains or physical or logical entities. It can be your own network or it can be a network from another operator which are leased. All bunch of things are tied together in a seamless fashion from a customer point of view. Also, orchestration plays a key important in some of the advanced services which are still sort of evolving, like 5G slicing. One of the fundamental things which people don't realize is in wireless networks, there is no concept of service level agreement or prioritizing certain services. It's equal opportunity. Everybody who has a phone can connect to a network in the same fashion as anybody else. There is no service level agreement. 5G was the first time the concept was introduced through a concept of slicing, where the whole 5G network end-to-end is partitioned to provide certain level of service level agreement for the end user. Dynamic scaling. Dynamic scaling in the sense that it's not just the network capacity, but also some of the resources, logical or physical. For example, adding more CPUs, adding more capacities to scale your edge network. Those kind of things, memory addition, all these things can be done dynamically in today's world with a cloud infrastructure. Multi-vendor environment, cross-domain automation. These are some of the areas orchestration plays a key role. And without orchestration, automation becomes fragmented, because what happens is orchestration acts like a glue layer to underlying automation pieces and some manual human interventions and all kinds of things. The next one is intent-based orchestration. This is where the full feature of control comes into play. Intent-based orchestration flips the model. Instead of telling the network how to do something, you tell what outcome you want, like telling a service level agreement. For example, tell this enterprise customer, give a 1 gigabit guaranteed speed with an SLA of 5 nines, something like that. Or optimize the cell site for gaming traffic during, say, evening hours or busy hour. Or reduce the energy consumption by 20% across the network. AI can take this information, this intent, and it turns it into actions. This is the foundation of autonomous network. The next one is closed loop automation. The network itself thinks for its capabilities. In closed loop automation, there are 5-step cycle. You first detect the problem, you identify the issues, you analyze the context and impact. Impact can be from various angles: network, customer, a specific vendor to some extent, all kinds of analysis. And then you make a decision and choose the best action and execute the action automatically. Now this is where the complexity comes into play. The decision making usually is in the human control, and to me that is going to be the last stop of automation, where humans are going to let go of their control. And I have been in situations where management in telco operators say that I don't want the system to decide things by itself without me telling them what to do. So there is going to be a lot of pushback on that area, but it's going to evolve and the role is going to be decreased over time. And once you execute the action automatically, obviously you need to verify it, whether it executed as expected or worked as planned. This loop can run in seconds or milliseconds or even days, depending on the type of problem. The closed loops can be reactive, response to specific issues; proactive, preventing issues before it occurs; predictive, anticipating issues. Like for example, if there is going to be a hurricane in certain parts of the country and you start preparing for it. These type of things are anticipating these issues, and you're trying to take proactive, predictive actions from a issue resolution point of view. Autonomous, optimize continuously. Closed loop are the core of self-driving networks. Then comes fault closed loops, fixing problems automatically. Fault closed loops have been one of the early lead user of automation. Alarm correlation, doing a root cause analysis, or we call RCA in short, automated remediation. These things, some of the fundamentals for a telco operator, and has been one of the leading areas where automation has been applied. It detects fiber cut, correlate alarms, identify the impacts of the services from a region point of view, from a vendor point of view, from a customer point of view, and then you read out traffic and verify the restoration. And all of this done most of the time today without human intervention. Now, how mature it is from an operator to operator obviously varies, but this has been put in place where people can take advantage of. Performance closed loops. Performance closed loop monitors the KPIs or key performance indicators that take actions and thresholds are breached. For example, increase capacity, adjust power levels, balancing load, optimize throughput. And this can be in a segment or end-to-end on a logical or physical or logical circuit. It can be any combination of anything. These loops keep the network healthy and efficient without a lot of manual intervention. Configuration closed loops. Configuration closed loops handles drift detection, auto rollback, policy enforcement. If a device drifts from an intended configuration, the loop restores it automatically. This prevents outage caused by misconfiguration and one of the biggest source of network failures. And to expand on that, every network device's configuration changes with new software patches or bug fixes, and it is usually done in a controlled fashion during a maintenance windows which operators set. And sometimes during the maintenance windows, the upgrade or change management doesn't go as planned. This is where the network failure occurs the most. Service assurance closed loops, protecting the customer. Service assurance is the fundamental of any service provider. It deals with fault data, performance data, inventory data, customer impact. They answer the most important question from a service assurance point of view. Is a customer affected? If there is a loop, will open the ticket, trigger a remediation, notify the customers and provide status on that customer, and escalate automatically to the necessary organizations, humans or systems, and get the problem resolved. This is where the OSS becomes customer centric. And you measure this performance using customer experience score and a whole bunch of things. Self-organizing network, we call SON. Self-organizing network is a mature example of closed-loop automation. This is mostly used in the mobile networks because mobile networks came in much later than the landline networks, but is being applied reasonably on a global level on the mobile side. It provides automatic neighbor relations like ANR, load balancing, coverage optimization, interference reduction between cell sites because signals usually overlap with each other, and the SON networks automatically identifies the key parts and makes sure that there's no overlapping in signals and thereby reducing the interference. And these are fundamentals for LTE and 5G networks, and it's going to get more and more mature as we deploy 6G networks. The challenges are there for closed-loop automation. Like any automation, there's always challenges. The key challenge is obviously data quality, false positive, or over automation. Like I said, if you can let computer do everything and without any human intervention, it becomes a little bit challenging for humans to fix the problem because they have no idea what happened. Vendor fragmentation, lack of standardization. Closed loop must be designed carefully with guardrails. Safety mechanism, keeping the automation under control, is very important. Safety mechanism can include guardrails, human override option, backdoor options, policy limits, making changes to the thresholds of the policy in a more real-time basis, approval workflows, rollback mechanisms. All kinds of metrics can be put in place to manage the safety of everything from process to workflow to controlling any automation with human level of governance. Automation must be powerful, but it has to be safe. In all, OSS has to provide these capabilities. Now, bringing AI into OSS, the intelligent layer, AI brings fundamentally 4 capabilities: prediction, which is forecasting failures and congestion; classification, classifying, categorizing alarms and events and suppressing them and grouping them in a certain controlled fashion for humans to consume or digest; optimization, finding the best configuration and providing recommendation, or in some cases taking actions on that recommendation; and then anomaly detection, usually looking at variations. This is mostly used in DDoS attack, where you have a network being attacked by external sources to come and inject viruses into your network. This anomaly detection usually spots these type of patterns. AI transforms OSS from being a reactive to predictive network. Machine learning pipelines and the brain behind automation. Machine learning pipelines include data injection, feature extraction, model training, interference, feedback loops. These pipelines continuously improve automation. Predictive automation and fixing the problem before it happens. Predictive automation uses AI expertise, predicting the failures, congestion, degradation of the network, and take necessary actions before even customer sees it or even affected. This is the holy grail of operations. And this is some of the areas a lot of research has been going on, especially in the service assurance area. Intent-based automation is the next frontier. Intent-driven automation allows operators to define the outcomes. AI translates these intents into policies, workflows, and actions, and provides a roadmap and how a network can be autonomous. Autonomous operation, level 5 automation. Autonomous networks are self-configuring, self-optimizing, and self-healing. Human defines the policies, but AI executes on those policies, which is the most interesting aspects of AI. The future of OSS. AI challenges the reality check. AI introduces biases, data drift, explanation, trust, governance. AI must be transparent, safe, and accountable. AI guardrails, responsible automation. This is the most important one where human provides a lot of value. Guardrails include human oversight, policy boundaries, safe fallback modes, audit trials, and of course, rollback mechanisms where in case something goes wrong, or something happens which humans are not anticipated or did not realize will happen. AI must enhance the operation, not endanger them. The future is basically a zero-touch autonomous network. This is where OS is going to go to. Zero-touch network where human intervention is minimized or literally none. Fully automated lifecycle management, autonomous network, AI native operations. Digital twins, a virtual replica for simulations and predictions. So people can in real time everything, sub-second loops, instant root cause analysis, instant optimization, which obviously a little bit far-fetched, but when you say near time, we can even use the word near real time, which is to a level where human beings can manage the real-time activity. Experience-centric operations. Customer KPIs becomes primary KPIs. The operator of the future is AI-assisted, customer-driven, and data-driven, automation-first, cloud-fluent, experience-focused. This new role is strategic, not reactive. So in closing, this is the episode where OSS becomes smart and intelligent. And that brings us to the end of episode 5, the automation episode. We explored the workflows, the policies, orchestration, closed loops, SON, AI, and a path to autonomous network. In episode 6, we shift to OSS in a cloud-native era, the platform that makes all of this possible. Thanks for joining me. We will see you in the next episode. Please like and subscribe me so we can provide you additional contact and let you know ahead of time. Thank you.